Hey there, and a massive welcome to all our Grade 7 learners joining us for today's explainer. I am so pumped to have you here. Today, we're diving into a really crucial Python lesson that's focused entirely on your environment setup and basic operation rules. If you've ever wondered how real programmers keep their computer workspaces from turning into total chaos, or why Python sometimes calculates numbers a little differently than your math homework, well, you're in exactly the right place. We're going to build a super solid foundation today so your code runs smoothly from the very first keystroke.
Here's our quick roadmap for today. We'll be tackling the Python setup claim, creating your safe environment, invoking the Python interpreter, a huge misconception about how division works, a reasoning and retrieval check, and finally, our lesson takeaway and review.
All right, let's jump right into section 1, the Python setup claim.
So right out of the official Python documentation, we have to ask ourselves a pretty fundamental question. Can one Python installation actually meet every application's requirements? I mean, think about it for a second. If you're building a bunch of totally different projects this year, are you just going to toss all that code and all those conflicting tools into one giant messy bucket on your computer?
Well, the answer is a hard no, and that brings us directly to our central claim for this explainer. You absolutely must set up an isolated virtual environment to safely run your Python inputs and outputs. This is our starting line. We don't just open a window and start wildly typing code. No, we build a protective, isolated bubble for our project first. That separation, that's exactly what keeps your code safe.
Which brings us perfectly to section 2, creating your safe environment.
The official docs completely hit the nail on the head here regarding why we need that bubble. They state, if application A needs version 1.0 of a particular module, but application B needs version 2.0, then the requirements are in conflict, and installing either version 1.0 or 2.0 will leave one application unable to run. It's kind of like trying to play a brand new video game disc on a super old console, right? If your projects are forced to share one environment, a simple necessary update for one project could literally break the other one entirely. Yikes.
So how do we actually build this protective bubble? Well, the documentation lays out a really precise two-step workflow for Unix and macOS systems. Step 1, you just type python-venv tutorialenv. This uses the venv module to spin up a brand new directory named tutorialenv that contains your very own isolated Python interpreter. Then step 2, you wake it up. You activate it by typing source tutorialenv/bin/activate. Once you do that, your terminal prompt actually changes to show you that you're safely tucked inside your new virtual environment.
Moving right along to section 3, invoking the Python interpreter.
Okay, so once we're in that safe space, we bring the interpreter to life by typing a specific command. If we type Python 3.14 into our shell, we drop straight into what's called interactive mode. The interpreter prints a nice little welcome message with its version number, and then it hands us the primary prompt. You know, those 3 greater than signs pointing to the right. When you see those 3 arrows, it means Python is literally sitting there, eagerly waiting to read and execute your commands.
But hold on, before we start typing away, there's a quick boundary rule from the docs we have to keep in mind regarding source code encoding. While Python is super smart and can handle characters from pretty much any language in the world for its text strings, the standard library actually uses ASCII characters for identifiers, like the names you give your variables. The docs specifically note this is a convention that portable code should always follow. So for maximum compatibility, we just stick to standard ASCII characters, basically the basic letters and numbers on your standard English keyboard.
All right, section 4, misconception, how division works. Now, what's really fascinating here is that this completely busts a massive misconception among new programmers. A lot of folks just assume the Python interpreter acts exactly like that standard pocket calculator sitting on your desk. But actually, it really doesn't.
Check this out. If you do classic division using just a single forward slash, say 17 divided by 3, Python spits out a floating point number. 5.6666666616667. Classic, right? But Python also has a totally different tool called floor division, and that uses a double forward slash. If you type 17/3, Python returns the integer 5. It completely discards the fractional part. No rounding up, no decimals, it just chops it off entirely.
And the reason for this strict boundary is actually all mapped out right in Python's standard library operator module. Behind the scenes, these symbols are triggering entirely different, strict functions. That single slash maps to a function called trueDiv, which gives you that big long decimal.
But the double slash, that maps to a function called floordiv. So Python isn't wildly guessing what you want, it is following strict predefined operator boundaries to the letter.
Let's put this into practice with Section 5, Reasoning and Retrieval Check.
Let's see if we've got a solid handle on Python's strict nature. I've got 3 interactive inputs here, taken straight from the official tutorial. Which one of these do you think is going to throw an error if you try typing it into a fresh interactive prompt? Is it the first one, 5 squared? Maybe the second one, the world is flat equals true. Or how about the third one, just the lone letter N?
Well, if you guessed the letter N, you absolutely nailed it. The first one just calculates 5 squared, giving you 25. The second one safely assigns the Boolean value true to a variable. But if you just toss the letter N in there without actually assigning it a value first, Python is going to hit you with a name error. The documentation shows it perfectly. Name N is not defined. Remember, Python doesn't guess what N means, it strictly requires you to explicitly define your inputs.
And that brings us to our final stop, Section 6, Lesson Takeaway and Review.
Before we wrap up, I want to quickly point out this number, 3.14. And no, we aren't suddenly doing geometry or talking about pi. In the context of our specific lesson environment today, this represents the exact version of the interpreter we invoked, Python 3.14. It's just a really solid reminder of our very first step, defining exactly which Python version our isolated virtual environment is running on. Which brings us to our ultimate takeaway for this explainer. Setting up isolated virtual environments and understanding Python's strict operator boundaries, like that huge difference between true division and floor division, are exactly what keep your code safe, secure, and totally predictable. By separating our workspaces and following the operation rules to a T, we stop those disastrous output errors before they even have a chance to happen. So you now know the vital setup steps and a couple of Python's hidden math rules. But hey, the operator module is absolutely massive. What other strict standard library operator rules are out there just waiting to be discovered? Keep that curiosity alive, Grade 7, because your Python journey is really just getting started. Thanks so much for hanging out with me today, and happy coding.